and welcome to today's webinar, DNS DDoS Protection and Risk Mitigation using Amazon Route 53 and AWS Shield. Our presenters today are Sergey Roit, Jeffrey Lyon. Sergey leads a team that focuses on Amazon Route 53 traffic management and health checking features. Additionally, Sergey's team works on core Route 53 infrastructure that provides high service availability. Jeff Lyons is a Technical Operations Manager for the Amazon Web Services. He leads the AWS DDoS response team, who is responsible for protecting AWS, Amazon.com, and its subsidiaries against the availability impact of distributed denial of service attacks. His team builds and maintains systems, tools, processes, and response capabilities that help defend the availability of applications in the cloud. Today with us, we also have Evgeny Golden, Matthew Mahan, who will be our webinar moderators today, answering the questions that you put in our Q&A panel. Sergey and Jeff, thanks for joining in with us. The floor is now yours.
Hi, I'm Sergey Roit, Development Manager on the Amazon Route 53 team. And today I'd like to talk to you about denial of service, specifically the DNS vector, and how Route 53 protects customers from such attacks. A denial of service attack is a coordinated action that can make your website or application unavailable to end users. In a distributed denial of service, also known as DDoS attack, multiple collaborators or compromised hosts participate simultaneously, generating a flood of packets or requests to overwhelm the intended target. In a DNS DDoS, the attacker tries to overwhelm the capacity of the target's DNS provider in an attempt to degrade or prevent DNS query resolution. Blocking DNS makes the target application or website unavailable to users, even if the rest of the infrastructure is operating normally. Mounting distributed attacks against DNS is quite prevalent due to the fact that it's cheap for attackers to orchestrate and is hard to block. The majority of DNS denial of service mechanisms target the performance of authoritative DNS resolvers. Attacks can focus on either the network and transport layers of the infrastructure or on the hosts that serve queries. So let's look at some most common attack types that are out there in the wild. Volumetric attacks are a crude and common type of DDoS. The magnitude of the attack is commonly measured in bits or packets per second. Although volumetric attacks are characterized by an enormous amount of traffic, sometimes in excess of hundreds of gigabits per second, they do not require a large amount of traffic to be generated by the hackers themselves. This makes volumetric attacks the most efficient type of DDoS in terms of cost to the attacker versus the damage generated to the target. Volumetric attack is an asymmetrical denial of service attack that aims to exhaust the network bandwidth. By leveraging a reflection medium, a small initial amount of traffic can be used to generate gigabits of volume. It is cheap to perpetrate, but can create a large impact on the intended target. The sheer quantity of traffic generated by an attack can prevent DNS resolution for the target, thus blocking access to the end resource. So that's the actual website or web service. Here's an example of an amplification attack in more detail. First, the perpetrator sends out a DNS query with a forged IP address, that's the victim's address, to an open DNS resolver, prompting it to reply back to that address with a DNS response. So in this case, the attacker looks to generate large responses, such as ones for query type any that responds with multiple records, or those containing many large records, such as IPv6 addresses or DNSSEC. With this method, a DNS request message of only about 60 bytes can elicit a response message of over 4 kilobytes to the target server, resulting in a 70-to-1 amplification factor. This gives attackers a lot of leverage and creates large volumes of traffic to the target. According to the Open DNS Resolver project, there are 32 million DNS resolvers that respond to queries today, and 28 million of those are at risk of exploitation by this type of attack. In contrast to the volumetric approach, the application layer DDoS is specific to a given communications protocol. Application layer attacks target the compute capacity of the targeted service. Attack traffic takes the form of well-formed application requests. Rather than blocking legitimate users' access upstream of the service, these attacks seek to disrupt availability by overwhelming the service with real requests that are not submitted by actual users. Application layer attacks against DNS are called query floods. Query floods are the most common type of DNS DDoS and can continue for hours, blacking out the target from legitimate users. In order to mount a flood attack, the perpetrator generally uses hosts to which they illegally gained access without the owner's knowledge or permission. These attacks attempt to exhaust server-side assets, such as memory or CPU capacity, with a flood of requests generated by scripts running on many compromised machines. Such fleets of hosts under the control of a malicious party are often called a botnet. Botnets can measure in millions of hosts that participate in multiple denial-of-service campaigns without the host owner even noticing. Bot traffic works to overwhelm authoritative DNS server capacity such that legitimate users are likely to get timeouts and, as a result, experience disruption of service. So with these DDoS trends in mind, let's look at some of the challenges customers have told us they face today when preparing for and mitigating attacks. The first challenge that we've heard is that DNS protections can be difficult to set up and deploy. Some things to consider: you must have a way to isolate domains. Organizations often have multiple domains, and it's highly undesirable for all to be impacted whenever a single one is attacked. Extra bandwidth is critical to be able to absorb the influx of traffic, and similarly, resilient solution needs to have extra server capacity and diverse geo-distribution of servers. All of this requires significant investment from infrastructure teams and takes focus away from investing into the core business of the company. Full protection is almost impossible to set up in an on-premise environment or when operating standalone DNS servers. Even for those companies that have the technical expertise and willingness to build a mitigation strategy, each event presents a unique challenge. Many existing anti-DDoS solutions require manual intervention by operators to initiate mitigation. This extends mitigation time, especially for large attacks, and as a result, quality of service suffers under attack, so the attackers get what they wanted. So even if you manage to keep your web application online during an attack, users may experience increased latency due to the rewriting of traffic. So external scrubbing centers cannot theoretically avoid reducing the quality of service for legitimate users. And finally, automated solutions for on-premise environments are expensive to deploy and maintain. There's the cost of DDoS mitigation service itself, cost of maintaining and installing scrubbing devices if those are used, and then the property owner is on hook paying for bandwidth and the personnel cost to manage all of this. So let's talk about Amazon Route 53. We know that many online property operators are concerned about being vulnerable to attack from large botnets, such as the recently infamous Mirai botnet. Route 53 hosts a large variety of customers, and as a result, we have been the target of countless denial-of-service attacks over the years. Luckily, the service was built to be resilient from the ground up, with a number of defenses in place. Let's look into some more detail. Route 53 is a highly available DNS service that is deployed to over 56 locations around the world. This number is constantly growing. We call those data centers points of presence. At any given time, each location is serving DNS queries from users in its general proximity. The network is also designed in a way that maximizes reachability in case of localized outages. As long as a user's connection is functional, there are multiple paths to reach Route 53 servers. This assures that a single Internet service provider or geographical region outage can be tolerated. Some of the largest recent DDoS events measure in hundreds of gigabits per second. Amazon Route 53 network has tens of terabits of capacity, owing to the fact that it is deployed collocated with Amazon's massive CDN, content delivery network. More network capacity is crucial in being able to absorb even the largest attacks. Each of Route 53's points of presence or locations has multiple transit and peering links, which provide diversity and redundancy in the face of DDoS-caused congestion. If there is an attack affecting a large Internet service provider or carrier, DNS traffic will be rerouted without end users experiencing an outage. High availability begins at the top of the DNS delegation chain. Each domain, or hosted zone in our Route 53 terminology, is assigned 4 name servers on creation. Each of those name servers is under a different top-level domain, which provides resiliency against top-level domain failures. Name servers are also highly geographically distributed thanks to the Route 53 network design. Name servers map to a global Anycast network of separate points of presence. Anycast is a routing technique where the same IP address is advertised on the internet from multiple physical data centers. Anycast allows each autonomous network to decide its optimal path to Route 53 and also provides network-level failover between all the locations. As a result, users get both low latency as well as exceptional redundancy. Under DDoS, this architecture has the effect of spreading attack load and making hotspots less likely. Additionally, the AWS operations team can make traffic engineering adjustments on the fly. Route 53 achieves a high measure of zone isolation through careful assignment of name servers. This is something we internally call shuffle sharding, since the logic resembles picking hands of cards out of a deck. Each individual zone gets a unique set of 4 name servers. No 2 zones have more than 2 name servers overlap between them. Because DNS resolution is resilient to partial failure, only 2 of the 4 name servers operating normally is sufficient for resolution to work with minimal latency degradation. All 4 must become non-responsive before there is a complete outage for a hosted zone. What this means is that any active mitigations affecting one victim zone do not impact any other zone that's not currently under attack. In summary, Amazon Route 53 is designed for high availability and is backed by AWS infrastructure, which runs at scale. The service is always over-provisioned for both network and server capacity, and we are backed by 100% SLA. 100% available means that Amazon Route 53 did not fail to respond to your DNS queries during a monthly billing cycle, DDoS or not. DDoS is top of mind for many of our customers. While Route 53 is built to withstand various attacks, we hear that customers want better visibility and better control over the health of their application in the face of DDoS. So at this point, allow me to hand it over to Jeff Lyon, who will talk to you about AWS Shield.
Thanks, Sergey. My name is Jeff Lyon. I lead the AWS DDoS response team. We're the team who is responsible for protecting AWS, Amazon.com, and its subsidiaries against the availability impact of distributed denial of service attacks. DDoS attacks are something that we have long considered And on AWS, we consider security to be job zero. So when it comes to DDoS attacks, we want to build capabilities that allow us to abstract away that problem from our customers so that you can focus on your business. And this is something that we've done for many years, but we haven't been particularly vocal about it. So customers were telling us, we want to know more about your capabilities, what you're able to offer, how is it that you help us mitigate these attacks. So when we launched the AWS Shield product just a couple of months ago, we released it in 2 tiers. The first tier is standard protection. This is available to every AWS customer on every AWS service at no additional cost. This is the same protection that you've always received for a number of years. Then we added advanced protection. This is a paid service that not only provides additional protection and additional capacity against some of the larger attacks, but provides you with some additional features that I would like to go into. But first, let's talk about what is AWS Shield Standard. So when it comes to protecting you against distributed denial of service attacks on AWS, we wanted to provide you with a capability that was fully integrated into the AWS global infrastructure. This means that we're not having to reroute traffic around the world just to mitigate these common attacks. Rather, when there's a DDoS attack against your application, we want to automatically mitigate that quickly at the point at which it ingresses into the AWS network. So when you think about Route 53 in our edge locations, we're constantly inspecting all traffic, and we have the capability of mitigating attacks in a matter of microseconds. And we're able to accomplish this because we don't have to wait for detection and rerouting of traffic to some remote scrubbing center just to be able to provide you with that capability. And in order to make sure we're actually able to mitigate these larger attacks and to make sure we're resilient against internet failures, we have redundant internet connectivity in many AWS data centers. So there's 2 key methods that we use to mitigate attacks. The first I want to talk about is deterministic filtering. This is where we know, based on some attribute of the traffic, we know for a fact that it's a DDoS attack, and we can very clearly and cleanly mitigate it just based on a known signature. And some of these attributes include things like an IP checksum, TCP flag combinations, payload length, which is the size of the packet we're receiving. And in the case of Route 53, we look at the DNS header. So if the DNS header is a real DNS query, we're going to allow it through. If it's something like a reflection attack or a DNS response, we know that Route 53 shouldn't be handling this kind of traffic, and it allows us to very quickly drop that traffic on the floor. The second method is priority-based traffic shaping. This is where the traffic we're seeing is a little bit more ambiguous, and we have to look at the suspicion attributes. So we look at 2 things. Low suspicion attributes are things that tell us the traffic is good traffic for real users of your application. And we look at things like the packet or request header, the composition of the traffic. Is it typical for its source or for the destination service? And then we look at high suspicion attributes. These are things like, are there suspicious attributes in the packet or request header? Is there entropy in the traffic by header attribute? Is there entropy in the traffic source or volume? So basically, is there some really weird pattern in where the traffic's coming from, or what kind of traffic is it? Or is the source of a poor reputation? Does it come from a network that we know normally sends us bad traffic? And in the case of Route 53, we have some other interesting priority-based traffic shaping attributes. One of them is a cache busting attribute. This is where an attacker will, say you have example.com, which is your application. They won't just make queries for example.com, they'll randomize it. So you'll see some random string in front of example.com, and they'll rotate that very quickly. And what they're attempting to do is to make it so that a recursive name server doesn't cache the result, so it continues to forward on that request to the authoritative name server, in this case Route 53. And that can be particularly challenging to mitigate because it looks like a flood of traffic coming from a common DNS resolver that's normally associated with good DNS services or good ISPs. So we have to have a way to know that this is happening, to deprioritize that bad traffic, and continue to prioritize the real human users. So here in the next slide, I have an example of what this actually looks like when we mitigate an attack. And this is a screenshot from a real attack that we mitigated, and you see some different bands on the graph. On the bottom, you see low suspicion packets that we chose to retain. And those can be anywhere from known good traffic to maybe slightly suspicious traffic. But what we're doing by retaining this is making sure that your real users are always getting a response from Route 53. Then we have the high suspicion traffic that we're actually dropping. This is the most suspicious traffic that we're nearly certain is absolutely part of that DDoS attack. And we're only shedding the amount of traffic that we need to drop in order to make sure that we maintain service availability. That way, the end user experience for your customers is seamless. Now I'd like to go into what is AWS Shield Advanced. So we talked about the different mitigation capabilities that AWS provides, and this allows you to stay online. It allows you to keep serving customers and focus on your business. But some customers have told us that's not all that they require. Customers require additional features, which I'll go into in just a moment, for services that are hosted on things like Amazon CloudFront, Amazon Route 53, and even your applications in AWS regions using things like Application Load Balancer and Classic Load Balancer. So the features that we offer with this advanced service are always-on monitoring and detection. We also offer advanced layer 3 and 4 and 7 DDoS protection. So these are the attacks like UDP reflections, UDP floods, SYN floods, and DNS query floods against Route 53. We offer attack notification and reporting and access to a 24/7 DDoS response team. Lastly, we provide you with cost protection so that in the event of a DDoS attack, you won't see an increase in your bill due to things like Route 53 queries, CloudFront request fees, and other AWS charges. So let's talk a little bit more about always-on monitoring and detection. So when you subscribe to AWS Shield Advanced, you receive additional monitoring capabilities. And when you protect a resource like a Route 53 hosted zone, we select that zone to receive additional monitoring on our network. And we provide you with things like signature-based detection. So if we see a known DDoS vector, we're able to record that and report it to you. We provide heuristic-based anomaly detection. So when we see interesting attributes in the traffic that could indicate a DDoS attack, we're able to detect that shift and also report that to you as a DDoS attack. And we do this by baselining your normal traffic toward your application or hosted zone, so that when there is entropy in some attribute or the volume of traffic, we have the ability to pick up on that and display it to you in your AWS Management Console or API. So let's go into the advanced layer 3 and 4 infrastructure protection. This comes in handy for those particularly large and difficult attacks. Sergey mentioned there's this new Mirai botnet and a lot of other botnets that take advantage of things like IoT. So we want to make sure we have a lot of additional capacity to protect you against some of these top-tier attacks. So when that occurs, we want to make sure we have distributed scrubbing and bandwidth capacity across the entire global infrastructure in those 56 edge locations. We want to make sure that we have automated routing policies so that when we need that additional capacity, we're able to shift traffic across the entire network. And then in the event that it's absolutely necessary, our operators will also have the ability to get involved and to move the traffic to other locations that have the available bandwidth or host capacity. So let's talk more about attack notification and reporting. With attack notification and reporting on AWS Shield Advanced, we provide you with real-time notification of attacks via Amazon CloudWatch. We provide you with near real-time metrics for attack forensics and historical attack reports. You can go back into your console or query via the API any events that may have happened in the past. And we'll retain that information for you. For the particular event, we'll retain that indefinitely. And for the CloudWatch metrics, we'll hold that for you for up to a year. So I wanted to provide some screenshots of what this actually looks like so you can get an idea of the additional visibility that you receive when you subscribe to the service and how easy it is to sign up for AWS Shield. So in this particular example for the screenshots I've taken, the account's already signed up for Shield. So what I did was I went in there, I clicked yes, I want to subscribe to AWS Shield Advanced. I typed I agree to some contract terms, and very quickly I was entered into this portal. And you'll see here there's a summary of protected resources, a history of events in the past 24 hours, and any resources that I've chosen to protect. And you'll see right now I have one CloudFront distribution and no attacks that have occurred in the recent past. So let's go ahead and add a protected resource. And we'll do that by clicking this blue button right in the center of the screen. And that'll cause this pop-up window that gives you some options for what resource would you like to protect. So I'll select a Route 53 hosted zone, and here in the example I'm using a domain that I call r53consoledemo.com. And you see there's some protections that are automatically enabled, and I just want to click Add Protected Resource. So we'll click that blue button in the lower right-hand side of the screen. And now you can see I've successfully added this hosted zone, and I have 2 protected resources. So now let's go see some of the historical incidents that have occurred on my applications in my AWS account. So we'll do that by clicking on Incidents on the lower left-hand side of the screen. And you can see here there's a history of events against an application load balancer that I actually no longer have on my AWS account, but you can see that there's still an incident history. So let's go ahead and drill down into one of these events and see the CloudWatch metric. And we'll do that by clicking on Attack Vectors. And you can see here that in the CloudWatch console, you can see via the metric for DDoS bits that there was an attack a couple of months ago, and you can see that plotted right here on the screen. And if you're familiar with CloudWatch metrics, what this allows you to do is not only visualize traffic or other attributes of events on your application, but it allows you to set alarms. And an alarm is an event that tells you or that allows you to automate different processes, either to notify an operator or to trigger something else in your application. So let's go ahead and I'll show you what it looks like to create a CloudWatch alarm. And you'll just want to click Alarms on the left-hand side of the screen. So I want to create this alarm by clicking the blue button. And this shows me the different CloudWatch metrics on which I can create an alarm. And we're interested today in DDoS attacks, so I want to click on the AWS DDoS Protection Metrics. And this is a new set of CloudWatch metrics that are available when you subscribe to AWS Shield Advanced. And you see that I've highlighted them here with the black box. And you have a couple of options. You can see the traffic towards your AWS resources in terms of DDoS vectors, or you can see the DDoS events that have targeted your application. So it's your choice whether you want to alarm on a level or volume of traffic towards the application, or if you want to simply alarm on the binary condition of yes or no, was there an attack toward the application. So let's go ahead and create an alarm that's based on the traffic toward a resource. And we'll do that by clicking right here where you see the red arrow. And you can see here I have the option to create an alarm with a bunch of different attack vectors. And you'll see I have SYNFlood selected. So let's go ahead and select that and click Next. And I want to define some parameters by which I want the alarm to fire. And so I'll go ahead and say when there's DDoS bits greater than 10 gigabits for 2 consecutive periods, that's when I would like to receive a notification. And what I would do in a real scenario where I want to create this alarm is I would create notification, and that would publish the CloudWatch metric to an SNS topic. And that allows me to do things like integrate with pager services to get operators involved when an attack occurs, or it allows you to integrate with anything else that you may want to program into your application to take action or automation based on the fact of whether a DDoS has occurred or whether it's occurred at a certain volume. And we'll just click Create Alarm. Now I want to talk about access to the DDoS response team. So normally as an AWS customer, if you're subscribed to business or enterprise support, you already have access to DDoS experts. And the way that you open a DDoS case is you simply go to the AWS Support Center, you select Distributed Denial of Service as your case type, and you type out whatever the issue is, and you can click to chat or click to call an AWS Support Cloud Support Engineer who can help you with that case. But when you subscribe to AWS Shield Advanced, you also have access to the DDoS response team. For those really complex cases where you'd like access to a team of experts, the same experts with deep experience in protecting AWS infrastructure and Amazon.com, you have that ability via AWS support. So what you would do is you'd open a case type the same way you always would, but then you can request escalation into the DDoS response team. And the way that you would do that is either by having the cloud support engineer indicate that DRT escalation is needed and performing that escalation for you, or you as the customer have the option of saying, I would like to request a DRT escalation, and that cloud support engineer will have the ability to very quickly spin up an incident bridge, page in my team, and then my team can get involved with your case very, very quickly. And there's 3 different mechanisms by which we can engage with you. We can do this during an attack, so when you notice that something's happened or that CloudWatch alarm fires and notifies you and you'd like additional assistance, we can get involved with that attack right there on the fly. We can do it before the attack. If maybe you received a threat by email, or maybe you're having a big event and you want to make sure that your security is covered, you can actually request an engagement with our team well in advance of the attack to make sure that you have an architecture review, that you're following best practices, and we can provide you with any advice that we might have regarding the threat environment or things that you can do to improve your security. And lastly, we can do a post-mortem analysis after the attack. So if you notice later that there was an attack via looking at your management console, or you see the attack on your API, or you just notice that maybe you had some issues with your application and you want to have a consultation, we can also get involved after the attack and help you analyze if any suspicious behavior you saw was in fact the result of a DDoS attack. And lastly, there's cost protection. So customers have told us it's important that when I'm in the cloud and I'm scaling my application, or I'm using services that are already operating at scale, like Amazon Route 53, that I'm not paying additional costs as the result of a distributed denial of service attack. So when you're subscribed to AWS Shield Advanced, things like CloudFront request fees, Elastic Load Balancer data transfer, application load balancer capacity units, and Amazon Route 53 DNS queries, if these particular utilization are elevated as the result of a distributed denial of service attack, when you're subscribed to AWS Shield Advanced, we're going to provide you with a limited refund of those charges so that you do not pay anything extra as the result of the attack. And that concludes our presentation. I'd like to now move over to our question and answer to help answer any questions that you might have about Route 53 or the AWS Shield service.
All right, well, thank you, and thanks for the great content today. Thanks for the good presentation. And so at this point, we're going to move on over to our Q&A section. You'll see the 3 polls at the bottom of the screen and one at the top of the screen. Your feedback is very important to us, so please take time to fill that out, and we'll keep these open as long as our Q&A is open. You can still ask questions in the upper left-hand corner of the screen. Type in your question and click the button to the right, and you'll notice there are some links on the screen you can click on to get the information. So at this point, we'll move over to our Q&A.
All right, thanks, Jerry. We'll just go ahead and start answering some of the questions that we know the attendees have. Just give us one moment to look over some of the questions that have already been asked, and we'll jump right into answering those questions.
And so I'll get started. There's a question. Nowadays, even CDNs are quite capable of handling large DDoS attacks. For example, Akamai can handle same level of DDoS. In what context should we go for Route 53? So thanks for the question. There are many reasons that customers choose Route 53, and those include just our feature set, our pace of innovation, cost is important for some. I can't really comment on Akamai's capabilities, but as for Route 53, I think our operational record speaks for itself, and you can see over the years all the events that have happened to various providers, and what you haven't heard from us is sort of that speaks to our rate of success. And as far as Akamai as CDN versus as DNS provider, Route 53 is a general DNS provider, so we have a lot of customers that are using us without using CloudFront or without even using other AWS services. So there's a lot of flexibility. There are a lot of things that our service provides, but what we are trying to show today, and hopefully you can agree, is that Route 53 together with AWS Shield also provides best-in-class DDoS protection. Thanks.
I'd like to add one point. If you are considering using another CDN other than Amazon CloudFront, we actually have ways that we can help you integrate Route 53 with that external service. So if you want to engage with our team, that's something we can also show you how to do. Another question we had, is it true that AWS can outscale a DDoS attack to the point where you can overwhelm them or turn the tables? So DDoS attacks are an asymmetrical problem where it's very easy for an attacker to launch a large flood. You can rent botnets, you can pay somebody just a few dollars even to launch an attack, and it can be very difficult or expensive to mitigate. And Route 53 is a service that operates at very large scale. So when we think about how do we protect against some of the world's largest attacks, we think about building out our network to the degree that we can handle these very large events. And as Sergey mentioned earlier, we scale with Amazon CloudFront. So if you think about a lot of these like big media use cases and big bandwidth use cases for which people use Amazon CloudFront, well, Route 53 is co-located on that same network. So this gives us very, very large capacity to mitigate the attack. And we do this fully in line at every one of the 56 edge locations. So when the attack comes in, we're automatically able to detect that attack, to score all the traffic inline, and to mitigate it without impact to your application or to your end users. So to answer the question more directly, can AWS outscale? So for CloudFront and Route 53, the services already operate at scale. But it doesn't mean that we want to receive every bit of traffic into the service. Rather, we use DDoS mitigation systems on our border and on our edge locations. We call these internally Blackwatch, and these are the systems that score all the traffic and do that mitigation for you. And then for any traffic we don't drop at Blackwatch, the services are highly resilient, can inspect that traffic also, and make sure they're dropping what they don't expect to receive, serving real users. And then there's other considerations outside of your DNS. For example, inside of your application, inside of the AWS region, you may be using services like EC2 or S3 or the application load balancer or ELB. And this is where it comes in handy to use a combination of strategies. So you can operate at scale by serving your application from the edge, and you can also outscale an attack when it comes to things like, for example, an HTTP flood, where you might just want to have extra application capacity to be able to deal with larger volumes of traffic before you have to start considering whether to drop requests that are coming in using services like AWS WAF, any capabilities you may have built, or even some third-party WAFs or other security appliances that exist in the AWS marketplace. So just give us one moment and we'll get to another question. Mute.
So there are a couple of questions. We're So people are asking, essentially, is Route 53 and Shield protection only for AWS resources, or can I put entries from my data center, hosted servers, and hybrid infrastructure there? And the answer is yes, as in we fully support hybrid infrastructure. So Route 53 is a authoritative DNS resolver. So you can host domains that are pointing to hybrid infrastructure, and the DNS layer of your infrastructure will be protected from DDoS, which is one of the most common vectors of attack. You would still need to worry about protecting the resources that DNS is pointing to, though.
All right, just give us one moment and we'll get to the next question. So we have a number of questions. How large of a DDoS attack can Route 53 handle? And we don't have an explicit limit that we publish, but what I can say is that we've built the service to be very large and operate at scale, meaning that many of the attacks, or every attack that we've seen towards the service, I should say, we've been able to mitigate. The capacity that we have available to us in the edge network is much larger than even the largest attacks we've seen to date. And that goes right back to some of the use cases that we have on our edge networks. For example, in CloudFront, we have a lot of customers with big bandwidth use cases. They're streaming media. They're offering big downloads to large numbers of customers and very large files that are being downloaded. And this can use tremendous amounts of network capacity. So we need to be able to provide our customers with an edge network that operates at scale to handle these types of requirements on demand. And so when it comes to distributed denial of service attacks, we also want to think about the direction of the traffic. So we build out and scale our network to handle all of these use cases. Well, those use cases are outbound heavy. That means there's a lot of eyeball networks that are requesting video streams, they're requesting downloads, and that traffic is going out from the AWS network. Rather, the DDoS attacks are coming into the AWS network. So what happens in practice is that we have very, very large amounts of capacity that are just sitting open and available that allow us to use our Blackwatch systems to mitigate the attack and still keep your application and your customers online. And just give us one moment, we'll get to the next question.
Okay, there's a question, does Amazon.com use Route 53? Are you dogfooding your own product? And if not, why not? That's a very good question, and we are definitely dogfooding, and I would say even more so, large and critical parts of Amazon depend on Route 53. So currently, and this is an experiment you can quickly do yourself, Amazon.com is on Route 53, and the majority of other AWS services are also hosted on Route 53, and we're in the process of moving all the other legacy names over as well. And I can take another one that's pretty quick. Does Amazon offer IPv6? And this question varies per service. For Route 53, the answer is yes. We fully support IPv6.
The next question, AWS shared responsibility model is defined for cloud security. Is there any specific shared responsibility model designed specific to DDoS attacks? So the AWS shared responsibility model also covers security, and we can consider DDoS attacks a security concern. So the way that shared responsibility works in this context is that you as a customer have a responsibility for security in the cloud. We have responsibility for security of the cloud. So that means that we are responsible for making sure that AWS and AWS services like Amazon Route 53 are always available for your use. And where the shared responsibility model can really come in handy when you're thinking about your architectures and the way that you're building out your application is that using Route 53 and using services like AWS Shield is a component of that shared responsibility, where you choose to subscribe to this service if you're going to subscribe to the advanced service, or just use the default protection that we provide you, but also consider what are some of the things that you can do in your own application, because availability in the cloud isn't limited to just DNS. Rather, you want to consider things like the web application layer. So when it comes to protecting your resources, your origin of the application, you want to think about things like, are you using ELBs or ALBs? Are you using EC2? If so, is EC2 set up for auto-scaling? Are you able to scale the origin in the event of an application layer attack? Because we find that the best mitigation strategies aren't simply detecting and mitigating the attack at the layer of our infrastructure. Rather, the customers we've seen who do this most effectively and have the best availability and experience for their customers are the ones who are not only taking advantage of our mitigation capability, but are also prepared to scale on their own application in order to use a combination of both strategies in case it makes more sense to serve the traffic in some cases versus using something like a WAF to try to drop a application layer request. And just give us one more moment, we'll get to the next question.
So quick question, does Amazon also offer domain hosting? And the answer is yes. If you go to the console, you can find a domain registration portion. You can register new domains or transfer domains. And another different question about Route 53 slicing or views. How is Route 53 sliced for public DNS and VPC? Is the same infrastructure serving both DNS queries from Internet and VPC? What techniques are employed to protect Route 53 for VPC? The private DNS and public DNS portions of Route 53 are actually disjoint, even though they're accessed by the same front-end API. So these are completely separate infrastructures, and the VPC portion, as you can imagine, since it's entirely in the cloud, we have a lot more control over what's going on in there. It's basically, it falls under the protections that are in place for EC2, the compute service, as well as AWS Shield comes into play within regions. So both are protected, and VPC is sort of a more controlled environment even.
Okay, the next question. A lot of this sounds like things that AWS does to protect their own infrastructure and make sure they can still serve AWS customers effectively. Can you speak more about how AWS Shield protects applications that we're running, or is it essentially the same? So for Route 53, it's a very simple service where if you're using Route 53 for your hosted zone, the protection of our infrastructure is your protection. Meaning if we're keeping Route 53 online, then effectively we're protecting the availability of your DNS hosted zone, and we're allowing you to serve your customers. On the other hand, some of the things that you can do, like I spoke about in my last response, the shared responsibility model, come down to the choice of services that you choose to employ. So for example, if you're using Route 53 for DNS, CloudFront for application delivery, and then you're using some of our best practices for your origin in the AWS region, this is where the combination of what we do to protect infrastructure and what you do to architect your application allow you to have the best possible defense. And part of that is really making a decision for yourself as to whether you would like to use the AWS Shield service that everybody receives free of charge, or the advanced service if you're concerned about needing things like additional visibility, additional support, and all of the different features that we spoke about. These are all considerations that you make in deciding how you're going to build your application and what level of availability or support that you require. There's also a number of questions about the different services that we support or what services we plan to support with AWS Shield. So right now, AWS Shield Advanced is supported on CloudFront, Route 53, ELB, and ALB. AWS Shield is supported on every single AWS service. And we're hearing a lot of feedback from customers about additional services that our customers are asking to also have protected with the advanced service. And what I can say is that we're always looking for new opportunities to expand the scope and feature set of our service. And we're taking into consideration the feedback that some of our customers have here today on the webinar to help us define our product roadmap. And just give us a moment, we'll get to the next question. Sorry for the delay there. I was just catching up on reading some of the questions. One of the questions we have, is there any use case to publish DDoS attacks against AWS CloudFront? So with Amazon CloudFront, you're able to protect your web application against any DDoS attack that might actually target the web application itself, not limited to just DNS. So for example, if there's a UDP flood, a reflection attack, a SYN flood against the web application itself, then you're able to use Amazon CloudFront to distribute your application on our network of edge locations close to your end users. And when you go out close to your end users to distribute the application, you're also mitigating the DDoS attack very close to its source. This provides you with a ton of additional capacity, and it provides you with failure isolation, where we actually have the option of isolating the DDoS attack to specific CloudFront locations and serving real users from other CloudFront locations to make sure that you have a consistent, reliable experience for your customers who are using your application. And this is an incremental improvement on the availability and performance of your application compared to just using services like ELB or ALB. And give us one more moment, we'll get to the next question. So we have a number of questions about protecting on-premise applications, so applications where the origin isn't necessarily hosted on AWS. So for web applications, you have the option of using Amazon CloudFront and Amazon Route 53 in conjunction with those applications that aren't even hosted on AWS. Using custom origins in Amazon CloudFront, you can tell CloudFront where to make origin fetches for content or for serving requests without you actually having to have the origin in an AWS region. That allows you to take advantage of these services. It allows you to use AWS Shield as your DDoS mitigation service, no matter where you've hosted that web application. And that about wraps up the time we have for a question and answer. I'd like to turn it over to Jerry to close us out.
This time I'd like to extend a special thank you to our presenters, Sergey and Jeff, for their time and a great presentation today. I'd also like to thank our moderators, Evgeny and Matthew, for answering the audience's questions today. If you have any further comments to one of our previous or upcoming webinars, or suggestions on topics you wish AWS to cover in future webinars, please feel free to email us at aws-webcasts@amazon.com. Your feedback will help us improve our webinar programming. So thank you for your time today, At this time, you can disconnect.